Okay. And this one will be about exposure. Okay, we have two types of radiation. There's ionizing and non-ionizing. The demarcation point is kind of like visible light. So when you get above visible light into the ultraviolet range, it starts to become ionizing radiation. What that means is it can change your cell structure, affect your DNA. So it can make permanent changes. In the case of ionizing radiation, light or infrared, which is where you get most of the heating from, when you get sunburn, it can be a combination of UV and infrared. The infrared is what heats up your body. Radio waves are down below the infrared, and they can also cause heating, but it's still not ionizing radiation. It's non-ionizing. Overexposure can really, cause some problems. You can get severe sunburns. In the case of radio frequency, it tends to heat up the soft tissue, things like your eyes and other soft tissue in your body, which can be very hazardous. So there's a standard of how much exposure you're allowed to have before it becomes dangerous. And you need to do calculations or measurements to determine how much radiation you're radiating when you transmit, so that you're not overexposing yourself or somebody else. So what type of radiation are radio signals?
Delta.
What type of radiation?
Non-ionizing.
Non-ionizing. Sorry, I wasn't reading it right.
How does RF radiation differ from ionizing radiation?
Alpha.
The higher the frequency of a electromagnetic wave, the more energy it has.
Are you reading the next question?
No, I was just telling you.
Yes, okay, sorry.
Okay. The FCC has set some exposure limits that were based on work done by the IEEE, and they use the IEEE chart for the amount of exposure that you're allowed to have over a wide frequency range. And it is frequency.
This exposure, what does it come from?
Well, when you're transmitting, your antenna is radiating electromagnetic waves.
Right.
Okay.
The higher up, the better.
If you've got 100 watts going into that antenna, it's radiating maybe 100 watts. Okay. And the radiation pattern from that antenna at different distances from the antenna is going to have a different power rating, which is done in milliwatts per square centimeter.
Okay.
And that's the chart that we'll see shortly. Is kind of plotting that. So,
So I want to have my radio as far away from the antenna as possible. No?
well, no, it's not your radio; it's you. You
That's what I'm
don't want
saying.
to
If
be
I rent my radio, then I'm going to be at the farther away too.
okay, but you don't want to be next to your antenna,
Nope.
and you don't want your neighbor to be next to your antenna.
Nope.
Like if you have a beam antenna, like a Yagi on a rotator, when you swing that around and it's pointed at your neighbor's house,
They
your
get it.
neighbor is getting radiated and doesn't know it.
Gotcha.
So the exposure limit for your neighbor, because that's called uncontrolled, is like 1/10 of what you're allowed if somebody knows they're being radiated.
Gotcha.
Oh,
So if you don't like your neighbor, you aim your antenna. No, just kidding.
Well, yeah, you could.
No, just
Because they
kidding.
find out, they could sue you.
Yeah.
Okay.
So you really need it as high as you could, as high as allowable for your equipment, correct?
that helps.
Okay.
But even the case of a handy talkie, if you do the calculation for the 2-meter band, you'll probably find out if it's one of these that can produce 5 watts or more, that you need to have it more than 5 or 6 inches away from you in order to not overexpose.
Right.
And also, the other factor is duty cycle, which is one thing that helps you. But if you were to continuously hold down the transmit button and have it right up close to you, you would get overexposed.
Yeah.
So you're required as a station licensee to also to ensure that no one, yourself or your neighbor, is being exposed beyond the limits that they specify. And there's 3 ways to determine whether you're in compliance. You can do some calculations based on this FCC bulletin. You can do it based on computer modeling, or you can do it by using a calibrated field strength meter and actually going around and measuring it. Now, those are kind of expensive pieces of equipment. Not many people do that. Or maybe a laboratory or some big commercial thing, but most amateurs wouldn't do field measurements. There's a lot of calculators available. There's one on the ARRL site, and there's others where you can actually plug in a few parameters and it will tell you what the exposure value is. You're required to have that information as part of your station information in case you were ever to get inspected. And also, if you change anything that would affect the radiation, like a different antenna, or you move the antenna, or you put in a power amplifier or a different radio, that you need to redo the calculations or measurements. So who is responsible for ensuring no person is exposed to RF energy above the FCC exposure limits?
Bravo.
oh,
As the licensee, you're responsible for your entire anything your station does, whether you're interfering with somebody or you're radiating somebody. Which of the following is an acceptable method to determine whether your station complies with FCC RF exposure limits?
Delta.
Delta.
One of the factors I mentioned is duty cycle. So the lower the duty cycle, the higher your power density can be. So if you're at 50% duty cycle, you can have twice the power density. If you're 25%, you could have 4 times the power density because it's averaged over time. And the duty cycle means the percentage of time that your transmitter is transmitting. So a 50% duty cycle means that you're transmitting for, say, 15 seconds, and then you're not transmitting for 15 seconds, which is the way the FT8 digital mode works. It transmits for 15, and then it receives and decodes for 15. And that's one of the higher duty cycles. Typically, if you're doing voice communications, your duty cycle is a lot less than that, and also your actual power, because it has to do with the loudness of your voice and the different frequencies. So you don't get 100% modulation when you're speaking into the microphone. So what is the definition of duty cycle during an averaging time for RF exposure?
Charlie.
Charlie.
What is the duty cycle? Why is duty cycle one of the factors used to determine safe RF radiation exposure levels?
Alpha.
How does the allowable power density for RF safety change if duty cycle changes from 100% to 50%?
Bravo.
Charlie.
By a factor of 2.
Let's go with Charlie.
Yep. Yeah.
You can have twice as much power for half the time.
Yeah.
Okay. The human body, the soft tissue in particular, absorbs RF energy at particular frequency more than others. And that's why the chart that's coming up somewhere shows, and it's basically in the 30 to 300 megahertz range. I think it's maximized around 50 megahertz. So that's where you have to be careful when you get to the very low frequencies and the very high frequencies. You can have much greater exposure. And the things that when you do the calculations with one of these calculators, you input the frequency, you input your power level, you input the duty cycle, and I believe there's some type of, I think it's like a multi-choice as far as the radiation pattern of the antenna. And it will calculate what the exposure level is at different distances. And here is the chart done by the, actually done by the IEEE. This one has been republished by the American Radio Relay League. And you can see here in the 30 to 300 range, that we're allowed 1 milliwatt per square centimeter. And, well, I thought it was a tenth, apparently. A fifth of that for uncontrolled, which means that somebody that is in the area and doesn't know they're being radiated. In other words, your neighbor or somebody walking down the street When you're transmitting, they would be in the uncontrolled range. So you would only be allowed to radiate them or expose them to 0.2 milliwatts per square centimeter if you were in that VHF band. Now, as you get up to UHF and super high frequency and above, you can see it's much greater. It's up to 5. And the low frequencies, down in the actually broadcast AM radio, you're allowed 100 milliwatts per square centimeter. Which means you could be much closer to an AM broadcast tower than you can an FM broadcast tower. So why do exposure limits vary with frequency?
Delta.
Yep, delta.
At which of the following frequencies does maximum permissible exposure have the lowest value?
Bravo.
Yeah, bravo.
So an upside down question.
Factors affect the RF exposure of people near an amateur station antenna.
All the above.
All of the above. Delta.
Okay. Like I said, you're required to redo the calculations anytime you change anything that could affect it. Just to be safe, anytime you change anything, you should redo it. I mean, if you use the calculators, it's pretty easy to do. And you can just print out the results, and that's all you really need to have in case you were ever inspected. And I guess it could also help if somebody was suing you because they claimed that you exposed them to too much RF radiation. You could show what your actual exposure calculations were. If you have, it turns out that you're getting excessive exposure to you or your neighbor, you could relocate the antenna or not point it at their house, reduce your power, or lower the duty cycle so that your average transmit power would be less. But you have to do something to mitigate the excessive exposure. Which of the following actions can reduce exposure to RF radiation?
Delta.
Yep. Oh, not increased. It's lower duty cycle, not increased.
Oh, too fast reading.
Yeah. Lower transmission. So yeah, alpha.
Too fast reading.
They snuck one in there, didn't they?
They sure did.
How can you make sure your station stays in compliance with RF safety regulations?
Bravo.
Bravo.
Okay, so we talked about the difference between ionizing and non-ionizing radiation. You get both of them from the sun. The ionizing radiation is what is a good thing as far as propagation, because that's what ionizes the ionosphere. Unfortunately, that ultraviolet light also can damage your body. Radio signals where we currently operate are not of sufficient frequency and therefore energy to actually cause any cell damage or DNA damage. As a station licensee, you're responsible to ensure that no one is being exposed to greater than radiation exposure, greater than the limits that they define. And there's 3 different ways to do the calculations or the measurement to make a determination. And remember, the duty cycle is percentage of time transmitting. So it's actually the average exposure that you're looking at. That's why duty cycle has an effect. The soft tissue in your body is more receptive to, I guess, heating around the 50 megahertz frequency, and definitely in the entire VHF band, which is why I said if you do the calculation for a handy talkie, which is going to be for 2 meters down in the 140 megahertz, you may find out that if you had a high duty cycle, you couldn't hold the handy talkie very close. Obviously, the distance of the antenna affects the exposure because it's a square law function with distance. So the milliwatts per square centimeter decreases as the square root as you get farther and farther away. Any questions on those?
So this is not on this, but so the discussion about whether cell phone